Thank you, I'm Toshiyuki. I'd like to talk about this title. This is the outline of my presentation. First, I'd like to introduce MSC of JMA. Next, I will give an overview of activities concerning the directory data activity directory out from your satellites and use of their data in JMA. And then I am going to talk about JMA's role in DBNet activities. Finally, I will introduce our plans for next generation satellites. First of all, I would like to briefly introduce the Meteorological Satellite Center, our center. MSC was established as an auxiliary organ of JMA on the 1st of April 1977. The mission of MSC is to observe meteorological and related phenomena from space using satellites, process observation data, and disseminate information and products derived from the data. These are main activities of MSC. This photo is MSC office building in Spain. Next, I'd like to give an overview of JMA's directory readout activities. JMA has acquired directory data from real satellites since 1968 and utilized the products for early detection of extreme weather events such as typhoon and heavy precipitation. These low latency data products also bring important benefits to numerical weather prediction around the world, including JMAs. JMA processes real data acquired at the Kiyose station and Syowa station and distributes products derived from it to DBNet. This figure shows the history of real satellites received at Kiyose for the last 20 years. I will introduce the Kiyose station and the Syowa station. The first is the Kiyose station, which is a receiving station owned and operated by JMA. This station is in Kiyose, Tokyo. It has one antenna and specifications here. Currently, these six satellites are being received. Reception range for Node 20 is shown in this image. The range for the other satellite is approximately the same. Next, the Syowa station. The Syowa station in Antarctica is owned and operated by the National Institute of Polar Research, NIPR. is a Japanese research institute that conducts research on Arctic and Antarctic. The main purpose of NIPR's direct readout activity is their research activity, and they transfers the data to MSC. Syowa station has two antennas, one for the L and S bands and the other for the X band, to receive data from these satellites. This slide shows the processing and distribution of the data in MSC. All data received at the Kiyose station is sent to the data processing system in MSC. On the other hand, only the microwave sound data extracted from the data received at Syowa station is sent to MSC. Because of limited capacity of the communication line from Syowa to Japan, these DR data are then converted to level 1 data by the processing system, and the level 1 data are sent to DBNet via GTS and to JMA's numerical weather prediction center via local network. And RDR data of ATMS and CRIS produced at MSC are provided to SSEC at the University of Wisconsin, and then level 1 data are made and distributed by SSEC. This slide shows how CSPP is used in DR data processing in MSC. We are currently using CSPP SDR version 3.2.1 to create SDR files. The created SDR files of ATMS and CRIS are converted to level 1 format by AAPP, and these level 1 files are used in JMA's numerical weather prediction. And we convert DS data from SDR to JMA's internal format to use it for monitoring volcanic ash. Let's see how long it takes to process the data at the JMA. These figures are histograms of the time taken to process Kiyose and Syowa data. The time from observation to provision of the data is generally within 20 minutes. This is fast enough for applications such as numerical weather prediction, which requires rapid data provision. And now I would like to introduce how JMA uses DR data. JMA is currently using DR data for a variety of applications, such as is listed here. Let's look at them in the following slides. First one is numerical weather prediction. A lot of their data are used in JMA's numerical weather prediction models. These pie charts show the percentage of DL data from Kiyose and Syowa station among the LEO satellite data used in JMA's global analysis and Mesoscale analysis. In the global early analysis with long data cutoff time, the percentage of data from Kiyose and Syowa is less than 2%, while in the Mesoscale analysis with short data cutoff time, the percentage from 9 to 20%. Their data is variable for JMA's operational and system, especially for short data cutoff time systems. Related to NWP, the use of their data for forecasting stationary linear mesoscale convective systems. Our recent focus of JMA will also be explained. Torrential rain events during East Asian rainy season in recent years were mainly caused by stationary linear mesoscale convective systems. These figures below show an example of a stationary linear mesoscale convective system that occurred in 2020. The heavy rainfall generated by this phenomenon caused rivers to overflow and many buildings to be flooded. In response to the situation, JMA began forecasting stationary linear mesoscale convective systems on this month. To improve the prediction for the phenomenon, it is necessary to enhance the accuracy of water vapor observations. Their data is very important as it contributes to improvement of NWP. And in relation to the stationary linear mesoscale convective system, I will introduce OSSCEs that we conducted in order to investigate the impact of hyperspectral IR sounder on geostationary satellite. For global model, nearly 140 kilometer improvement in typhoon position for 3-day forecast. For mesoscale model, better location of the heaviest rain area, which caused devastating floods. Next, about volcanic ash monitoring. JMA operates Tokyo VAC and provides volcanic ash advisories in the East Asia, Northern West Pacific region, and part of the Arctic Circle. Tokyo Park uses satellite data to monitor volcanic ash in the regions. Real data from real satellites are particularly useful for high-latitude volcanic ash where geosatellites have low resolution. This infrared image of NOAA-90 AVHR data, real data, shows ash ejected from the Khrushchevskoye volcano on the Kamchatka Peninsula. Next slide is about JMA's aerosol products. JMA retrieves the aerosol optical depth and Armstrong exponent from their data. We use these products to monitor Aeolian dust. Aeolian dust is a kind of aerosol blown up from semi-arid area of the Asian continent and transported by westerly winds to Japan. The left figure shows the aerosol optical depth derived from NOAA-19 area HRR their data. Aerosol optical depth is larger here in the region where Aeolian dust is suspended. This slide is about sea surface temperature analysis. JMA analyzes SST for use in fisheries, weather operations, and boundary conditions for JMA's NWB models. The DL data, as well as the global data from real satellites, are used as input data for SST analysis. Next slide is about sea ice monitoring. Sea of Okhotsk, which is in north of Japan, is the southernmost sea in the northern hemisphere, where sea ice is observed across a wide area. Sea ice hinders marine output, damages fishing facilities, and can obstruct shipping lanes, leading to accidents at sea. JMA uses real data to monitor sea ice around Japan. This image is an RGB composite imagery created from Meteorological AVHR real data, which makes it easier to distinguish between clouds and sea ice. Moving on to the next topic, I would like to explain JMA's DBNet activities. JMA plays an important role in DBNet as a sub-regional network coordinator on AP-RAS, which is responsible for coordination and management of activity of DBNet stations in the Asia-Pacific area. This figure shows AP-RAS networks. Data processed each AP-RAS station is sent to JMA in Tokyo or BOM in Melbourne, and then it is distributed to DBNet. JMA also operates the APRA's website. This website provides these contents listed here. And the URL is here. On the following slides, I will introduce two of these contents shown in later. The first one is navigation difference time series. This content shows time series of the average navigation difference between global and real data for each station. Ideally, navigation in global data and navigation in real data should match, but in practice, there is a slight difference. Each point in this diagram represents the average difference of buffer data provided from each AP large stations. This figure helps early detection of problems in real data processing. For example, using outdated TLEs. Next one is timeliness monitor. This figure shows a histogram of the time taken from satellite observation to data dissemination for all APRA's receiving the stations. The MSC website also has histograms for each station that are not shown here. This content also aggregates the time it takes from observation to data delivery, as well as the time consumed at each stage of the process to help the centers identify problems. In DBNet, each center aims to deliver data to user within 30 minutes of observation. The green line in this figure marked at the 30 minutes. Finally, I would like to introduce the plans of JMA and NIPR for the support of the satellite scheduled for launch in the future. Both JMA and NIPR have plans to receive JPSS2 and MetaPSG data. JMA plans to replace the antenna of Kiyose station in January 2023 to receiving coming new satellites JPSS2 and MetaPSG. NIPR intends to continue their activities and has included JPSS2 and MetaPSG DR1 in their next 6 years plan. This is the summary of my presentation. JMA has acquired their data from geo satellites for over 50 years. JMA uses CSPP Software to process their data we greatly appreciate the cooperation of SSCC students. JMA uses their data for a variety of applications. JMA plays an important role in DBNet as a sub-regional network coordinator on Asia-Pacific RAS. JMA has plans to receive JPSS2 and MetaPSG. This is the slide. Thank you for attention.
Thank you, Toshiyuki, for that excellent overview of JMA activities related to direct broadcast. Are there any questions for Toshiyuki? I have a question about, I don't know if you'll know the answer to this or not, but about future satellite programs at JMA and support for direct broadcast. In other words, is the plan to continue supporting direct broadcast, or is it more of a transition to, for example, the cloud?
We don't have plan.
Too soon to tell? Huh? Is it too soon to answer that question?
Yeah, yes.
Okay. Any other questions? Okay, thank you very much.
Thank you.